Changing paradigms in compute are the inflection moments where wealth creation is possible and typically happens. This is a very big statement. I can't emphasize enough how important this is, because I think it really ties together how technology and wealth creation work. And the purpose of Orange Capital Partners is to create wealth by investing in fundamentally new concepts and engineering practices. Now, we could actually expand that statement and the purpose statement and really talk about changing compute paradigms, because that's where fundamentally new concepts and engineering practices actually come to fruit. Now, before I go there, a couple of things. There's assumptions underlying this thesis. One of them is that compute is absolutely paramount when it comes to wealth creation. That is not necessarily the case. I mean, you might think that living in the digital age of 2022, yeah, obviously, particularly, we just relocated to Los Altos in Silicon Valley. So, of course, we're biased. But we also have to acknowledge that sometimes, let's say, innovations in aerospace or innovations in other physics, such as making better wind turbines, could change the energy sector. Finding oil in 1850 something in Pennsylvania, that wasn't necessarily compute. Now, we've spoken about this many times before, that we believe that any kind of progress in life always works through iteration, and compute is just another way to accelerate or enable iteration. Or in other words, in a very practical way, let's say if you want to find oil, you can just go around and try to dig holes, or you can use models, geophysical models, math, physics, technology, whatever you have, and then model this stuff and then find the oil much faster. So information is power, information is energy, information is, in the end, wealth creation. This is what we understand when we say compute paradigms. But fundamentally, again, most importantly, the change in compute paradigms, that's where the wealth is created, because it creates new markets. That's simply what it does. It creates new markets on the supply side, so we can find companies that are not trillion-dollar companies yet, and then they become trillion-dollar companies, or even trillion-dollar companies can become multi-trillion-dollar companies because of the change of compute. This is the key thesis. This is not even on podcast. It's September 8, 2022. This is Krim Delco. Since the last update, we're up roughly 5%. The market's up 3%. For the year, we are down 28.2%. The market is down 16%. We're underperforming by 12.2%. Changing paradigms in compute are the fundamental source of wealth creation opportunities. This is the statement. And now I want to elaborate what that means. What is compute? What are paradigms? What is wealth creation opportunity? I want to talk about all this, parse this in a way that hopefully is understandable to the audience here. The purpose of this podcast is to give people a sense for what it feels like to run a hedge fund. And I think there's nothing more important than this. This is one of the most important episodes that we have in this Not Even Wrong podcast, because I think it really gives a nice overview over how we think about wealth creation. Just before I go there, this is not investment advice. Please do your own work. The idea here is really to give people just a sense for how we're thinking, and hopefully it helps, inspires people to think their own ways and to navigate their own ways through the jungle of the financial markets. But now let's talk about, so a change in compute paradigm means that there's different ways to do compute. So for example, we have the mainframe in the 50s and 60s, which was constrained by physical and technological and economic limitations. So for example, memory was very expensive. The processors, the actual arithmetic logic units and all those things were very limited also. So what you had to do is you had to put, let's say, an executable file into a very specific environment. You didn't have a lot of memory, so it had to be dynamically computed, or you had to use some sort of dynamic logic where input and output are in real time, and then you had to somehow find the result and save it somehow, maybe on tape or whatever. So it was very, very expensive. And then the paradigm changed when memory became cheaper, and at the same time also the arithmetic logic units and other parts of the processor became relatively cheaper and more powerful. So what you could do now is you could go from the mainframe to the personal computer, because you had the ability to use the von Neumann model, which is the von Neumann compute model. On top of my head, don't remember the exact details of the von Neumann compute model, but the concept is that you have a general purpose compute model where you have memory, where you have a central processing unit, where you have interconnects, input, output, and storage, and I think that's about it. And that you can put any kind of program into this computer and execute anything on this computer, at least anything that is knowable to humans and that we know how to do. Now, this concept was more enabled on the personal computer because memory became cheaper. Fast forward, we have the internet. That's another compute paradigm, which is, let's just call it distributed computing. So now you have, let's say, executable files on one computer and the actual logic unit on the other, and then you send the file and then execute and tell the other computer, execute this for me, and then store the data on a third computer. So you have this distributed concept, which was then, of course, pioneered by people like Oracle, and then definitely commercialized to a very large extent by Amazon. And today we have AWS, Azure, and Google as the big cloud providers. We also have Oracle and other companies, IBM, that are in the business, Dell, VMware, but those are the main ones. Now we're talking about the next, let's say right now, as we speak, sitting here in Silicon Valley, I think it's fair to say that the next compute paradigm shift that is happening as we speak is what I call Software 2.0, borrowed from Andrej Karpathy, former head of AI at Tesla. What that means is that, and this is also somebody else, Mark Andreessen, definitely somebody who knows something about software and what's going on right now in Silicon Valley, said the same thing. What we have is this new type of software development where you create algorithms and then you feed them with data and then they start executing things based on the data. So this is sort of the machine learning model, if you want, another compute paradigm shift. I think the biggest shift right now that we're seeing as we speak in terms of also startup investing is blockchain technology. What that compute paradigm means is that we have the solution to the Byzantine general problem. That means we have Byzantine fault-tolerant systems that then can execute in a very decentralized way all kinds of things, and that model is so new that we don't even have good applications other than things like Bitcoin that are being used. But we can see where this is going, and we've spoken about this many times on this podcast, where we have the ability to, let's say, change society. We have the ability to codify law in terms of smart contracts and a lot of other things. And most importantly, to paraphrase Silvio Micali, founder of Algorand, we have the biggest power ever, which is to decide what is and what isn't. And that is now being taken away from individuals or organizations or any kind of human conglomerate to something like a protocol or an algorithm. So those are the big compute paradigms that we're talking about here, that we know of, that we care about. And now I want to talk a little bit about why are they so important in terms of wealth creation, and where is the connection here? I mean, you can have paradigm shifts in many areas. You can have paradigm shifts in physics, chemistry. I would argue that the compute paradigms are critical for two fundamental reasons. One, every business is essentially a compute business. So anything you do in life, if you want to scale it up and become very good at it at low cost, you have to find a way to use compute to your advantage. Let me give you an example. Yesterday, I had a flat tire, and my car had to be towed, and the guy who towed my car, came with a truck, and he towed my car and all that. And my point here, this guy really doesn't have a lot of opportunities to increase his business, scale up his business, or any kind of, because it's labor, it's the truck, it's going from A to B, towing the car. There's not a lot of things you can do. Now take another example, Walmart. Sam Walton starts a retailer, and he starts using relational databases to basically figure out where stuff is and start scaling up a logistics system, which then morphs into Walmart. There's certainly a compute model underlying this ability to do all of that, and the ability of the relational database, like I said, the lower cost of memory and lower cost of arithmetic logic units and all kinds of other things. So having said that, why is this an opportunity for wealth creation? because compute allows companies to iterate and make mistakes and learn very fast. The cost of iteration is a lot lower with compute versus without compute. In other words, yeah, I mean, you could have to do what Sam Walton did by just try and error, but it would take generations and generations of Sam Waltons to figure out by try and error how to optimally network routing and retail locations and all of that stuff. Of course, that would be ridiculous. So compute is also another way to increase evolution, the speed of evolution, to increase the inverse of entropy, which is what evolution really is. So you find ways to organize yourself, ways to organize your business around the very volatile nature, and that is the opportunity for a business. So if you have a problem, you can solve it, and compute helps you solve that problem much faster. That's why there is this opportunity to generate wealth through compute. It's not a foregone conclusion, and I would say I'd be happy to discuss that with people who have other opinions. But again, from our perspective, the way we see the world at Orange Capital Partners is we look for paradigm shifts in compute, and then we look for companies that are good at adapting that compute towards a business problem. And then hopefully the market is very large, and the company, by using the compute in very intelligent ways, can gain market share and also differentiate themselves from competition. This is, in a nutshell, what Tesla is doing. And there's other examples, but we don't want to talk about Tesla in this particular episode, but just as a really sort of prime example, Tesla is using compute to their advantage to change the transportation market, the energy market, and many other markets. Amazon did the same thing for retail and also for compute itself. Amazon is actually a paradigm changer in compute. Tesla is not so much. They're using paradigm shifts that have happened and just apply them to their own advantage. I don't think that Tesla themselves necessarily have the potential or even the will to become a compute company. So why is this so important? Again, it's important because paradigm shifts in compute create new markets. There is a seminar I recently listened to by A16Z, and they talk about blockchain technology. And what's really nice about this, without going into the details of the topics discussed, is that you have university professors, entrepreneurs, seasoned venture capitalists, people, smart people with lots of experience, and they talk about these new things. Let's say in this case, it is how to design blockchains so they're large scale attack resistant. How do you design Byzantine fault tolerant networks that are efficient and high performing and low cost? And those are all new problems that we've never had before. And therefore, there is no such thing as somebody who's done it all and seen it all. There are no people out there who have an infrastructure or are already at a point where they can say, look, I'm much better than anybody else. I already have an infrastructure. I have built all of this, so you can't compete with me. None of that. It's all basically a free-for-all. It's a Cambrian revolution of ideas and hopefully at some point interesting business models and then wealth creation opportunities. So what I'm trying to say is that you have this sort of level playing field, a true level playing field where experience, money, capital, age, none of that matters. It's all about pure creativity. It's a Popperian way of solving problems, finding new problems, solving problems, building an innovation stack. All of these things are playing at the best when there is a complete paradigm shift in compute, because that enables new markets, opens up new markets, both on the supply side, meaning people that can actually deliver businesses, and also on the demand side, people that can ask for services. For example, the new blockchain technology will hopefully one day replace a lot of the legal mumbo jumbo that we have to deal with today by simply having smart contracts and protocols executing against people's actions and so on and so forth. So that's why this is so important. And again, maybe to finish this episode, I want to remind people that we at Orange Cap Partners, our strongest belief in wealth creation is always around iteration. Iteration is the key. We have the concept of the natural Sharpe ratio, which is some sort of ratio. Without going into details again, it just encompasses the ability to iterate, and it also puts some constraints towards that. For example, if you iterate a lot, you want to make not too many errors, and if you make errors, you want to be able to correct them fast, and if you correct them, it shouldn't be costing you too much to correct them. So all of those constraints are incorporated in our natural Sharpe ratio. But what's important here is, again, because of the natural Sharpe ratio, we have the necessity of compute, which enables fast iteration, low cost iteration, low cost cost of errors, and all of those things. So compute is the key, and paradigm shifts in compute are the key to wealth creation. And before I end the episode, I just want to actually give another example. And this time, it's not going to be Tesla. It's going to be our CRISPR portfolio, and why we think that there's a direct relationship between CRISPR and compute. Again, CRISPR technology that allows us to edit genes to, as we say, digitize life sciences. So take life sciences from the bespoke alchemist approach towards a more first principles digital science, where you have a certain, let's say, bit stream or information, and then you can create functions, constant functions that say, okay, if I have this type of information, I can transfer to that type of information, and this is the outcome. So, for example, we have the knowledge of DNA, we have the knowledge of how DNA transfers itself into, how DNA transfers into protein, and then the proteins, thanks to AlphaFold, we have now a good sense for also how proteins fold, and the folding of proteins defines the actual functioning of proteins. So we can go from this to there and back, and also return. So meaning we can start with a bit stream of, let's say, DNA, and then basically go from there all the way to the function, or we can go from the function and then infer, okay, if this is the function, then this should be the DNA. So we can go back and forth, and this allows for much faster iteration, which will hopefully allow much faster development of medicine and other life science problems, such as pharmaceuticals, medical, and agricultural issues. And if we can solve problems within that realm with digital technology, then we can create many new problems. One of them being, for example, what kind of computer devices should we develop to accelerate genomics, which is what Onur Mutlu is doing in his courses. And this is a very nice example of how we solved one problem, which is how do we digitize life science. And we already created a much new problem, which is even a better problem, which is, okay, what kind of compute device do we have to design that is, data centric, that doesn't consume too much power, and allows us to do, let's say, much faster genomic sequencing. Thank you.